Okay, so we continue to study about the production sector. So this is the second video for week 7 and the second part of chapter 6, the production sector. Okay, so we've pretty much briefly defined a production function. Okay, so I believe all of our students are pretty much familiar with the basic concept of function, and we can just apply this type of mathematical concept into the production sector. So a little bit of abstraction and a little bit of the stylizations of the production mechanism with the language of mathematics. Okay, so in production sector, it is really important to separate the types of cost, because as we discussed before, the profit maximization problem is equivalent to the cost minimization problem. So the structure of cost is really important to be understood by the student at this point. So we can go over the types of cost. So to define the types of cost, we firstly define the types of the time in the point of view of the producers. Okay, so we can briefly separate the times into the two parts. The first one is the short term, and the other one is the long run. Okay, the short term is defined by at least one of input is the fixed in the short term. And the long run is a time span where all the inputs are the variables. Variable input means that it could be controlled over time. It could be varied over time. The fixed input or the fixed cost means that it is not varied over time. So it is just fixed constant number, because we define a function as the combination of numbers, right? So the output of the production function will be given by a specific number, the amount of number, like 100 or 1,000 or something. Also, the input, labor, and the capital will be estimated by the number, 100 or 1,000 or something. So the fixed input means that it is not a variable. It is a constant in the production function. Okay? So a producer cannot control over the fixed input in the short term. But in the long run, there is no fixed input anymore. So all the inputs, such as the labor, or such as the physical capital, or such as the material things, all of these variables are just a variable, not a constant in the long run. Okay, so this is the definition of the short run and the long run in the microeconomics. But in macroeconomics, the definitions of the short run and the long run, or the difference between those two concepts, are a little bit different. But we are living in the microeconomic world, so we can define the short run and the long run as it is, right? So in mathematically, we can express the short run production function as the equation number 3. Okay, the small q is still the amount of output. Okay, and the output will be given by specific mechanism or specific technology of the function of f with the labor L and the capital K. But the only difference between the equation number 2 and the equation number 3 is that there is the over bar on the K side, which means that the capital in this case is fixed. So we cannot vary the amount of capital in equation number 3. So bar means that it is a constant, a fixed term here. But we can still control the amount of labor input L freely from 0 to the infinity if we hire the infinite number of workers. But we cannot control over the physical capital K in the short run in equation 3, which means that in short run, in the example of the chicken restaurant, you cannot expand your business in the short run. In 2 days or in a month, then you can use the same equipment, the same factory or same machine for producing the chickens, but you can control the labor part, which means that you can cut any lazy workers or you can hire more workers in the next day or two. So it is still a bearable in your side, in your business, or in your production function in your mind. Okay, so the labor is still our bearable input, but the K, the physical capital in a month or in 2 months, which means that it is a shortened, it is the fixed input, so we cannot control the amount of capital. Okay, so just an example. So this is table. This is just example of table. So it's a given table. We can observe the evolution of our output or evolution of our production function in the short term. Why do you think this is the short term production? Why do you think or why do you believe it is a short term, not long run production process? Because we see the number of capital, the K, is not changing over the output increasing or output revolution. Okay, so the capital K is fixed at 8, so we can give them the bar or the hat because it is a fixed, but we can see the labor is evolutionizing from 0 to 13. So we can say that, okay, so labor is now our bearable input while the capital is the fixed input. So we are living in the short run at this point because we cannot control the amount of the capital at this point or in the near future. So as we expect, the output or the total product, the small q, will be also evolutionizing because we see the input will be increasing. At least the increasing of input is done partially because we cannot see the capital is increasing, so only the labor part is our increasing input. But by increasing one of two inputs, the total product or total output Q will be also increasing. It is our normal expectation. So this is until the third column. The complicated part is the fourth and the fifth column of the table. On the first column, we see the new concept or the new definition, the marginal product of the labor. In shortened representation, it is MPL. Okay, so the marginal product of labor we'll define later. It is the difference between the product and the next step, the product. Okay, so in the first column is the blank because in the first column there is no starting point. There is only the end point, 0 and 0. Okay, so we don't have any marginal product of labor at the first column. But in the second column, we see that our output is increasing from 0 to 5. So the marginal product of labor, because we see that the labor is increasing by 1 unit. So this is really key concept to define the marginal product of labor. As labor increasing by 1 unit, the total output increasing by 5 units. So the marginal product of labor in this period is the 5 units. Okay, let's see the second step. The labor is increasing by 1 unit more, from 1 to 2 from the second row to the third row. So labor is increasing by 1 unit. How about the output? Output increasing by 13 units at this point, from 5 to 18. So the marginal product of labor increasing by 1 unit, but the output increasing by 13 units. So the 13 over 1, 13 over 1 is the 13. So the marginal product of labor is 13 at the second stage. Okay, so you can calculate over and over by yourself. So if you go over until the last row, you can see some interesting result. Your marginal product of labor can be negative. Let's see labor increasing from 12 to 13. Okay, so you can just keep increasing your labor, which means that you keep hiring more workers in your kitchen, in your chicken restaurant. I'm always confused between the chicken and kitchen. Even I'm 37 years old, I'm really confused still with those two words, chicken and kitchen. Okay, from 12 unit to 13 unit of labor, your total output is now decreasing from 108 to 104. So the marginal product of labor is -4, which means that how do you interpret this result? Which means that you're hiring too many person, so you are not efficient anymore because your marginal product is negative, which means that as you hire one more unit of labor, your marginal product from that additional unit of labor is decreasing right now. Oops, sorry, my bad. Right? So, do you understand that? Okay. So, how about the last column? The average product of labor. Average product of labor is defined more easily. Your total output over your total labor. So, you cannot take derivative anymore. So, it is also, there is no APL at the first stage because there is no denominator at this part. Sorry, there is no numerator at this part. So from the second stage, you have one labor and you have 5 product. So 5 over 1 is 5. So it is your APL at the first stage. The second stage, you have 2 labors and you have 18 units of quantity. So 18 over 2 is 9. So 9 is your APL or your average product of labor, the second stage. So as you expect, average product of labor cannot be negative because your total product is always positive. If your total product is negative, it is insane business. So it does not happen usually in our real world. So your total product is usually positive number. And your total labor is also positive because there cannot be a negative hiring of workers in our real world. So positive divided by positive is positive. So your APL could be always positive in real world, but your MPL or your marginal product of labor could be negative because it could be defined a little bit differently. Okay, so this is table, and now we carefully define each of pretty much important concept. The total product of labor, it is the amount of output, the total output at this point that can be produced by the given number of labor, because we don't think about the capital at this point because we are living in the short-run situation. So the total capital or average capital or the marginal capital is just fixed with the constant term. So we don't have to think about it anymore because it is just equal to the constant number. So now we are just think about the labor and the total product. Okay, so the total product of labor is defined easily, but the problem is the marginal product of labor, which is a little bit complicated to some students. So it is defined by the change of total output. So now we can invite the delta. Delta means the change of Q, the change of the total output, which is resulted from using an extra 1 unit of labor, the change of labor, holding the other factors like capital or technologies or any materials or the environment are just constant, the same. Okay, so if everything else is the same, the change of total product caused by changing 1 unit of labor, which is the marginal product of labor. So it is defined more mathematically or more conceptually, like equation number 4. The marginal product of labor is defined by the change of Q over the change of L. So if you are more familiar with the mathematics, it is just taking derivative of Q with respect to the L, or the slope of the production function. the product function will be usually the increasing function, but it could not be, or it might not be, the linear increasing function. So there might be different slope at each point. So the slope at each point of the product function will be defined by the MPL. Okay. So this is practice for us. Fortunately, we have the linear production function. The Q equals to the F of L and K. So your total output will be the result from any kinds of production mechanism using the two types of input, the labor and the capital. And this technology is now fully given. It is clearly informed to us, which equals to the 2 times L plus the K. So since the L and the K, there is no polynomial things. So since L and K are two linear function, and summation of two linear function is the linear function, so your total production function is a linear function. Okay. The question is, what is the shortened production function given that the capital is fixed at the capital equals to 100? So our production function Q is now changed to 2 times L plus 100, my expectation. So what is the marginal product of labor? Which means that you can take derivative of Q with respect to the L if you are familiar with the mathematics. But if you are not familiar with the calculus, then you can just follow the steps in the next page. The first step, set capital into the constant, 100. So now we don't have to think about the K. K is not the variable anymore. It is just 100 constant term. So our short run production function is now changed from 2 times L plus K to 2 times L plus 100. Okay. After that, the second step, you can determine the marginal product of labor by putting the delta L into a function and calculate delta Q over the delta L. How to do that? Like equation number 5. The delta Q is now equal to the 2 times something, and the 2 times something in the parentheses is very important. 2 times parentheses open L plus delta L, which means that now you can add delta L into our equation number 4, the original form of the production function, to find out the delta Q. Okay. So the first big parenthesis is after changing product, and the second parenthesis, 2 times L plus 100, is the before changing the total product. So the left-hand side of equation number 5, the delta times Q, is the change of total product. So to calculate the change of the total product, you can make the new after changing the total product and subtract the before changing the total product from the new after changing the total product. Okay, so the middle section of the equation number 5 is doing that process. And I guess the constant term will be cancelled out each other, and also the 2 times L part is also cancelled out each other. The only remaining term is the 2 times delta L. So by definition, the marginal product of labor is defined by delta Q over delta L. And in equation number 5, we can find out delta Q over delta L, which will be equal to 2. So the marginal product of labor is just 2, which means that how to interpret this one, that is the most important part. The answer number 2 means that if you change 1 unit of labor in the shortened production function, your total quantity of output will be changed by the 2 units. Okay, so now you can expect at every point of the production function, because this is a linear function, the slope is the same. If you change your labor by 1 unit, which means that you can hire one more person or something, then you can expect increasing in total output by the 2 units. Okay? At every position. So this is why the linear production function is unrealistic. It is criticized by many economists by doing that. Because if we go back to the example of your chicken restaurant, hiring a third person in a small business is not the same with the hiring the 100th person in the same space, the same, because we assume that the capital is fixed. Because 100th person hired by you does not have many things to do. Maybe he can smoke for every time, or he can just texting their friend every time, because 100 people in small space is too many. So maybe output cannot be increased by that guy. But if we hire the second guy, or if we hire the third guy, the contribution of that guy will be huge. So the output will be increased by big number. So that's the reason why many economists does not assume the linear production function. But in this practice problem, just doing things much simpler, we use the linear production function. Okay. The average product of labor is simpler to be defined. So it is defined by the ratio between the Q and L. Q divided by L. So it is easy. But there is one thing to be careful about, which is that it could be buried over time. It could be buried over the point, because the Q and L will be evolutionized in every point. So the APL will be different at every point, even in the linear function. Okay. So here is one more important findings by the economist in this APL and the MPL findings, which is called the diminishing marginal returns. If we assume the capital is fixed in the short run, only the labor is our variable input, our marginal returns, or the marginal product, will be decreasing over the unit of labor, which means that if you hire more and more people to your business, the additional contribution of that hiring worker will be getting the smaller and the smaller. It is more realistic assumption than the linear production function. Okay, so let's see our third column and the fourth column first. A labor is increasing by 1 unit, just 1 by 1, from 0 to 13. Okay, so labor is increasing linearly, just 1 by 1. And your output is increasing faster at the first part, but in the second and the last part, it is increasing slowly or even decreasing at the end of the production, as we discussed before, right? So the marginal product of labor is pretty huge at the first stage of the business. You can easily think of the expanding business situation. If you open your own business with your own family member, there is a small number of participants, but maybe revenue is pretty large. So the marginal product or marginal revenue is pretty huge at the first several weeks or the first several months of your business. But as you expect, there will be more success in your future, so you hire the more labor, then they're definitely increasing some product, but the additional contribution of the additional worker will be getting smaller, because there isn't much things to do for the additional worker. So the additional contribution will be smaller, which means that there will be diminishing the marginal returns to the total product of your business. And if you see the fourth column and the fifth column, you can find out one interesting findings, which is that there is some relationship between the ampere and the APR. How about the APR first? APR is increasing, but it is increasing, but at some point it starts decreasing, right? So it is inverted U-shaped, okay? Or just a bell types graph. How about the marginal product of labor? It is increasing really faster. Then after that, it decreasing, even going to the negative part. Let's see the graph of the ampere and the APR. Oops. So the blue line is our ampere, and our green line is our APR. So ampere is increasing, then decreasing, and APR is also increasing, then after that it is decreasing. How about the point B? At point B first, B is the highest point of the APR. It is maximum. In more mathematically, it is local maximum point of APR function. Your ampere graph will cross that point, and it will be always. So that is our first finding. Your ampere graph will cross the maximum of APR. That's the first one. And the second one, there is some changing moment in the total product. What is that? That is the top picture of this one. So in top picture, our total output is increasing and increasing infinitely until the unit of labor, which equals to 11. But as we see in the table, if you hire the 12th unit of labor, then your total output will be decreasing. So the marginal product of labor is decreasing. Sorry, marginal product of labor is negative, right? So before until the 11 units of labor, your total product is increasing, but the shape is a little bit different. It is a little bit fluctuated, right? At point A and the point B, there is kinked point here. Not actually kinked point, but it is more like their intersection point, 변곡점 or something. Okay, so at point A, there is the first intersection point or 변곡점. From that point, there is the starting point of the diminishing marginal returns. Okay, until the 4 units of labor, as we see here, until the 4 units of labor, your ampere is increasing. But after 4 units, your ampere is decreasing, but still positive. But after the 12 units of labor, now it is going to the negative. It is shown in the bottom picture with the blue line. Okay, so at the point A, there is the starting point of the diminishing marginal returns. Okay, and the point B, the ampere graph crosses over the APR as the maximum point. So we can find out the 2 findings here. Okay, a little bit complicated, but it is interesting findings because it is universal, which means that it is not the specific example of this one. You can find out these universal rules over all the examples with the shortened production process. Okay, so this is the reason why it is called the law, which is the law of diminishing marginal returns. If a firm keeps increasing input, holding all other inputs and the technology constant, so the mechanism of technology does not change and the capital does not change, the only variable input is the labor, the human capital, the corresponding increases in output will become smaller, which means that your returns, your marginal returns will be smaller. You can still have some positive product until really that point, but your marginal return or your marginal product will be decreasing over time. It is a law. because my interpretation about this law is that getting expanded your business has some risk, because your additional hiring worker will be not so much efficient as your first hiring worker. Okay, because the contributions will be trapped, will be separated with many workers. So there will be some holes which is not under your management. So there is some inefficiency in working system, and it is represented in our law of diminishing marginal returns. Okay, so this is the part of the short run production function, and next time we'll study about the long run production function. It's a little bit different because we can relax one more assumption that the capital is not buried. Now in the long run production function, we will assume two buried inputs, the capital and the labor, right?